Addition and subtraction with polynomials is really just an exercise in combining similar terms. If we want to simplify 2x squared minus 3x plus 10x minus 15, we see that the only terms that are similar are these two middle terms. So the best we can do on simplifying this is to write 2x squared plus a negative 3x plus 10x will be 7x minus 15. So that's how we simplify this expression right here by combining similar terms. And our next problem, we're going to do subtraction with two polynomials, and you'll see it really amounts to combining similar terms. So here I have this trinomial, and I want to subtract from it this trinomial. So what I'm going to do first is think of this as a negative 1 times each term in here, so I can remove all the parentheses and just have all my terms lined up. So I'm going to take an extra step here. This will be 5x squared minus 6x plus 1 minus 4x squared minus 7x plus 2 when I distribute this negative 1 times each term inside there. Now I can change the order and the grouping here if I want, but you know what's going to happen. Let's just add similar terms. 5x squared and negative 4x squared will be 1x squared. Negative 6x and negative 7x, when I add them, I'll have negative 13x. And positive 1 and positive 2, when I add those together, I'll end up with 3. So doing subtraction, I have an extra step here where I have to remove these parentheses. When I remove the parentheses, it changes the sign of each term inside the parentheses. That gives me this. From this point to this point, it's simply a matter of adding similar terms. Let's look at one more simplification problem. Let's just simplify this. I'll use my rule for order of operation and go into the innermost parentheses first. I want to remove them. I'll think of this as a negative 1 times each term inside. So I have 4x minus 5 times 3 minus x plus 4. And I've replaced these brackets with parentheses. Continuing to simplify, I have 4x minus 5 times 3 plus 4 is 7 minus x. Now I'll distribute the 5 and take the negative sign with it, thinking of this as addition of negative 5 times all this. So negative 5 times 7 will be negative 35, which I'll write as 4x minus 35. Negative 5 times negative x is positive 5x. I see I have two similar terms, 4x and 5x. That will give me 9x minus 35. So three different looking problems, each of which, though, really amounts to simply an exercise in combining similar terms. Our first problem with multiplication with polynomials is really just an application of the distributive property. We want to multiply 4a cubed times 3a squared minus a plus 1. By the distributive property, we know that will be 4a cubed times 3a squared minus 4a cubed times a, that's that term, plus 4a cubed times 1. So you can see by the distributive property, I've distributed that 4a cubed across this sum and difference here to each term. Now multiplying here, I have 4 times 3 is 12. A to b, I add exponents. 3 plus 2 is 5. Minus 4. A to the 3 plus 1 is 4. Plus 4a cubed times 1, which is 4a cubed. So there's my product, 4a cubed times this trinomial right here, and it was simply a matter of applying the distributive property. Let's look at the product of a binomial with a trinomial. What we want to do when we multiply this binomial times this trinomial is multiply each term here times each term here. We can do that in a sort of organized fashion by writing the 2a minus 3 underneath and then using something that looks similar to long multiplication. Let's try 2a times 3a squared. When I do that, I'll end up with 6a cubed. Now 2a times negative 5, negative 10a squared. 2a times 1 will be 2a. That takes care of this term 2a times each of those three terms. Next, I'll go to the 3, and I'll take the subtraction sign with it, thinking of this as plus a negative 3 times each of these three terms. Negative 3 times 3a squared will be negative 9a squared. I'll write that underneath the term it's similar to. Negative 3 times negative 5a, positive 15a. And negative 3 times 1, negative 3. So I've lined up similar terms. Now I'll simply add 6a cubed minus 10a squared plus another minus 9a squared will be minus 19a squared. 2a plus 15a, 17a minus 3. So here is the product of this binomial with this trinomial. And the rule is really multiply each term here times each term here. This is just a method of accomplishing that, which looks similar to long multiplication with whole numbers. Here's our next example. I have this binomial times this binomial. I want to multiply each term here times each term here. So I'll start with 2a and multiply times 3a. That will give me 6a squared. 2a times 2 will give me 4a. Now I'll move to this term and multiply 3 times 3a. That will give me 9a. And then 3 times 2, that will give me 6. Now combining similar terms, I have 6a squared plus 13a plus 6. So here I've multiplied each term in the first polynomial with each term in the second polynomial sort of in a linear method or in a straight line like this. I could have used the column method that I used on the previous example also. Let's try one last problem. X minus 2 quantity cubed. By definition, this is x minus 2 times x minus 2 times x minus 2. So let's multiply x minus 2, that's this, by what I get when I multiply these two together. X minus 2, I'll have x times x, which is x squared. The last term will be positive 2 times, negative 2 times negative 2, which is positive 4. And the middle term comes from these two multiplied together plus these two multiplied together. So that's negative 4x. Now I need to multiply x minus 2 times this. So let's do this in a sort of a column arrangement. X times x squared, x cubed. X times negative 4x, negative 4x squared. X times positive 4 plus 4x. Now, negative 2 times x squared, negative 2x squared. Negative 2 times negative 4x, positive 8x. Negative 2 times positive 4, negative 8. So here's my column arrangement again. Now I'll just add similar terms and get x cubed minus 6x squared plus 12x minus 8. So there is the answer to the quantity x minus 2 cubed. It'll be x minus 2 times x minus 2 times x minus 2. And that's a look at some problems that involve multiplication with polynomials.